Today we're going to talk about buffers. So what is a buffer? A buffer is essentially anything that can donate a proton or it can accept a proton. So what does that mean? So if you're in a solution, an aqueous solution, and you have a buffer, if you add an acid to it, an acid's going to want to readily donate its proton. So if you have a buffer in that solution, the buffer will accept the proton from that acid, whereas if you add a base to your aqueous solution, a base is really going to want to accept a proton, so your buffer will be willing to donate its own proton to the base. So there's a couple different locations or ways that this can be used really well, and the most important is in the body. It's just maintaining homeostasis, making sure that the pH stays around 7.4 at all times. And then another way that we can examine buffers is with titration curves. So basically a titration curve is where you either start with an acid or a base in a container with a certain concentration. So we'll have an M for molarity and a certain volume. And then you're going to add either an acid or a base to this container to make the overall pH neutral. So if we look at this, if you examine a titration curve, so let's say that within our vial we have an acid, and we're going to add a base. So the first thing you're going to want to do is find the equilibrium point. And the equilibrium point is where the constant, or your moles of acid equals your moles of base within this actual container. So the way you do that is it's with the molarity equation. You first determine, based off your volume and your concentration, how many moles of acid you have in this container, and then you determine, based off the concentration of your base, and how many moles of base you need to have, which is the same amount of moles of acid you have, you determine how many liters of your base you're going to add to this container. So your equilibrium point is going to be your liters of titrant, and titrant is the solution that you're adding to your container. And so that's going to be your goal to find. And if you're looking at a titration curve, there's going to be three main points on this curve if you're looking at a monoprotic acid or base, that is one that only accepts or donates a single proton. So on your x-axis, you're going to have volume of titrant. And on your y-axis, you're going to have pH. So if you're starting with an acid in your container, your initial pH is going to be very low. So you're going to start right around here. And as you add more and more base, you're slowly going to come up until you have a slope of 0 essentially right here. And then you're going to add so much base that the pH is slowly going to become more base until it bottoms out at a high pH up here. So this point right here that we've x'd, this is your equilibrium point. And that typically is going to be at pH equals 7. And then down here is before you've added enough base to get to your equilibrium. So this is your acidic range. And then up here is going to be your base range. Now, if you started in the opposite way and you had a base in your container and you were titrating with an acid, your curve would look slightly different, but it's still the same concept. So you're still going to have your volume of titrant down in the x-axis. You're still going to have pH on the y. And now, instead of starting at a low pH, you're going to start at a high pH. And you're going to start off pretty basic, and then all of a sudden you're going to go to a neutral with a slope of essentially 0, and then bottom out an acidic range. So they're both the same curve, it just depends on whether or not you start with a high pH or a low pH. And then based off this curve, you can do different calculations to determine your pH. and other values. So that's the basics of buffers and titration, and hopefully that all makes sense.